Hello friends, in this video we see definition of group and examples of groups. Before it we will see some of the important applications of group theory. In art and design, group theory explains patterns and design in art, helping artists create symmetrical works. In robots and animation, group theory helps in programming robots and creating animations by managing movements and the rotations. In cryptography, group theory forms the basis of many secure communication systems, helping keep our online data safe. In music, group theory analyzes patterns in music, like how melodies can be transformed or rearranged. In chemistry, group theory helps scientists understand how molecules behave and their shapes, which is important for things like drug design. And in physics, group theory helps scientists categorize tiny particles and how they interact. Now let's see the definition of group. A non-empty set G is said to be a group with respect to an operation star if it satisfies following four conditions. Condition number 1. For all A and B belongs to G, means if you take any two elements A and B of G, then A star B must be element of G again. This is called as closure property. The property number 2. For all ABC belongs to G, means if we take any three elements A, B, C of G, then A star in bracket B star C is same as in bracket A star B star C. This is called as associative property. Property number 3. For all A belongs to G, there exists an element E in G such that A star E is equal to A and E star A is also A. This element E is called as identity element of G with respect to star, and this is called as the property of existence of an identity. Property number 4. For each A belongs to G, there exists an element B in G such that the product of A and B is identity element E and B star A is also E. And this element B is denoted by A inverse, and this property is called as existence of inverses of elements A in G. Means if you have any set G and satisfies this property with respect to operation star, we have to call that set G as a group with respect to operation star. And suppose we have a set G which does not satisfy any one of these properties, we say that the set G is not a group with respect to star. Means to be a group, this set G must satisfy all these four properties. Let's see some of the standard examples of group. The set of integers Z forms a group with respect to addition because it satisfies all four properties of group. Let's see the first property. If you take any two integers, their addition is again integer. Means Z satisfies first property. Second property. If you take any three elements, if you take any three integers, their ABC, they satisfies associative property. Identity element 0 is there with respect to addition, means if we take addition of any integer with 0, we get that integer only. And inverse of each integer is present in set of integer, means if we take inverse of 1 is minus 1 because addition of 1 and minus 1 is 0. 0 is nothing but identity element of Z with respect to addition. See, inverse of minus 3 is 3 because addition of minus 3 and 3 is 0. Inverse of 2 is minus 2. Similarly, if we take any integer a, its inverse is minus a because addition of a and minus a is 0. Identity element. Okay, let's see second example. Set of rational numbers q with respect to addition also forms a group because it satisfies all four properties of group. Similarly, set of real numbers with addition is also a group. Set of complex numbers also a group with respect to addition. Set of non-zero rational numbers Q star is a group with respect to multiplication. Similarly, set of non-zero real numbers R star is also a group with respect to multiplication. Set of non-zero complex numbers C star is also a group with respect to multiplication. Set of residue classes modulo n denoted by z suffix n, it also forms a group with respect to addition modulo n. Set of all prime residue classes modulo n Zn star is also a group with respect to multiplication modulo n. The symmetry group Sn consists of all permutation of set with n elements. Permutation means a bijective function from any set to itself, it called as permutation. Means here if we take any set containing n elements, then Sn contains all the bijective functions from that set with n element to itself, and this set forms a group with respect to composition of functions, and it is called as symmetric group Sn. The d-hedral group Dn represent the symmetries of a regular polygon with n elements including rotations and reflections. This set Dn also forms a group. Klein-4 group K4, it is a group containing 4 elements E, A, B, C. E stands for identity element of this group and A, B, C are non-identity elements. In this group, if we take any two non-identity elements, then the product is nothing but remaining non-identity element, and each element is inverse of itself, and this set forms a group. And since this group contains only 4 elements and it is this group it is observed by mathematician Klein, it is called as a Klein-4 group. The set of all matrices of size m by n with real entries, it forms a group with respect to addition. Similar set of all non-singular square matrices of size n by n with real entries, this set also forms a group with respect to matrix multiplication. These are the some of the standard examples of group. You can construct more such examples. Take any set and take any operation, and if the operation satisfies all these four properties, taking elements of the set, then we have to call that set as a group with respect to the operation. And if it does not satisfy any one of the property from the group, then we say that it does not forms a group. Let's see some of the important properties of group. If G is a group, then the identity element of G is unique, means any group contains exactly one identity element. Every element A of G has a unique inverse in G, means if we take any group G and its any element, then it has unique inverse in G. For every A in group G, inverse of A inverse is original element A. And for all AB belongs to G, inverse of product of A and B is equal to product of B inverse and A inverse. One can prove these four properties easily. These are the standard results of group, any group. I am stopping the video. Thanks for watching it. Thank you.